It starts with a chip.
A chip?
Yes.
Like a tortilla chip?
No.
Like a potato chip?
No.
Like a tooth chip?
No.
Like a gravel chip?
No.
Like my uncle chip?
No, you dozy bitch. You give incest a bad name. A chip is an integrated circuit as can be found in most electronics. It is comprised of layers of components insulated by silicone into a small package. The central chip for the circuit we are going to build is embedded inside the plastic of the flickery LED, as seen in this close-up photograph. First, a few introductions. This is a circuit board. This is a flickery LED, or light-emitting diode. This is a normal LED. This is a 270 ohm resistor in series with a 330 ohm resistor for a total of 600 ohms of resistance. These are two 12 ohm resistors that will be soldered in parallel to obtain a total 6 ohms of resistance. This is a PNP transistor. This is a 4.5 volt battery pack. It takes 3 AA batteries. This is an 8 ohm speaker. First we must consider a translation from schematic to circuit. A schematic is a representation of the circuit that does not account for the limitations of the circuit board. The circuit board used here is composed of holes grouped in threes by copper traces. Each component will have an opportunity to share a trace with up to 2 other components. The long copper rail along the edge of the circuit board is the ground trace. Now, down to business. First we solder the cathode of the flickery LED to ground. The anode of the flickery LED shares a trace with one leg of 600 ohm resistor pair. The other leg of the 600 ohm resistor shares a trace with the base of the transistor. The base of the transistor is the middle leg. The right leg of the transistor is called the collector and shares a trace with the anode of the regular LED. The cathode of the regular LED shares a trace with one leg of each 12 ohm resistor, both of which then connect to ground. The left leg of the transistor, called the emitter, shares a trace with the positive red lead of the battery pack. The negative black lead of the battery pack goes to ground. Finally, one leg of the speaker shares a trace with the anode of the regular LED. The other leg shares a trace with the cathode of the regular LED, which we find is the fourth leg to be connected to a 3-hole trace. So we improvise until a secure connection can be achieved. Then we pop in 3 AA batteries to the battery pack and listen to the sound of our flickery LED. Voila!